How are you? My name is Abraham. Today we want to learn something new on logic gates. So these are digital electronics. We'll talk of logic gates. So what is a logic gates? A logic gates is a circuit with one or more input but one output. It have only one or more input with one output. For example, we'll talk of three major or basic gates. We'll talk of three basic logic gates, logic gates. And the first one is an OR gate. The first one is OR gate. The second one is AND gate. The second one is AND gate. The third one is NOT gate. NOT gate. So we only have three gates. The first one is OR gate. The second one is AND gate. And the third one is NOT gate. Now, let us discuss one by one. Let's start with OR gate. Let's start with OR gate. So OR gate, it have an operation of addition, and OR gate have an operation of OR gate. We can say something. An OR gate is a logic gate that has two or more inputs. So an OR gate have additional operation like this. Now let's draw an electrical circuit. Maybe we have a switch here and another switch here, and we connect it to a bulb. There is a source of EMF. There is a voltage here. So this one is A and B. So we want to try to draw the truth table of an OR gate. A truth table of an OR gate. Let's say these two are inputs and output as this Y output. Now we are going to have A and B. This one is our Y. Now let's say false and false. False and false means that both the switches are off. Both the switches are off. And let's say the A is true, false. The true side means the switch A is on, but switch B is off. What will happen? And let's say this one now is false, and this one is true. And all of them are true. Now when this bulb A and B is off, that means there is no current that will flow to this bulb. Therefore, what we'll have here is off. Our bulb will be off. And then when we have a true and false, on and off, we will have a light here. There is a light. Of course, this one will have a light. Of course, the same will have a light. Now, with an OR gate, we can now draw a truth table using this one. You can draw a truth table. Let's draw the truth table. The truth table of an OR gate. Now, the input, the output. The input are A and B, and the output are A. Because we have a sign and OR gate is a positive, we can say A plus B. Or rather, you can say Y is equal to A plus B. Now, in a truth table, you use, you can say 0, 0, 0, 1, 1, 0, 1, 1. Maybe you don't know how to find these values, you can use this method, the method of 1 to 2, or 2 power 0 and 2 power 1. 2 power 0 is 1, 2 power 1 is 2. Now, you'll be in the first value, that is b, we'll have 1 0, then 1, 1 0, then 1. For this one, you'll have 2 zeros and then 1 1. That is how we obtain this one. And it is the same for this false, that is 0 0. For example, here we could have a false and true. For example, this one we can say this one is again false and true. And then we say here it is true and false, and then true and true. Very good. Now here we'll have, when it is 0 0, we don't have any light, so here it will be 0 1 1. And that is the true table of an OR gate. So what you need to say, an NB, the output, you can say that the output is high. The output is high if any or all the inputs, if all inputs are high. The only way to get a low output, is by having all input low. So this one is an OR gate. We say that the output is high. High means 1. If any or all the inputs are high. That's why if we have any as 1, the result will be 1. If any is 1 or all is 1. But the only way to get a low output is by having all input low. For example, 0 0. Very good. Let's continue discussing AND gate. Let's continue discussing an AND gate. No. Before AND gate, let's draw the symbol of an OR gate. So this is a symbol of an OR gate. Let's clear this one. Symbol of an OR gate, just like this. And you're going to have, this is B. You're going to have A plus what? Plus B. This is the symbol of an OR gate. And let's continue and discuss AND gate. Sorry, let's just do this one for the sake of our viewers. Again. Let's discuss an AND gate. What we can add in OR gate is connected in parallel, where an AND gate is connected in series. An example, this is a switch, this is another switch, and this is a bulb. Let's say we put an EMF here, the voltage, this one is Y, this one is A, and this one is B. Now, here in an AND gate, we will only have light when A and B, both A and B are high. So let's try and draw an AND gate truth table. So let's just write this one and write here AND gate. Then we remove this one, we remove this one, we remove this one. So an AND gate, we say an OR gate have a positive or addition operation. An AND gate have a multiplication operation. So it have a dot. So, for example, here we are going to have 0, 0, 0, 1, 1, 0, 1, 1. Therefore, when we have 0, 0, this switch is on, off, off. The result will be 0. When this one is off and this one is on, the result will also be 0. When this one is on and this one is off, the result will also be 0. When this one is on and on, we'll have a line that is 1, and that is 1. So NB, you can say something small on AND gate. Say that AND gate, the output is high. The output is high if all the inputs are high. However, the output are high. However, the output is low if any or all inputs are low. So, in an AND gate, the output is high, and high means 1. You know, these logic gates are just switch, so it's high when it's 1. If all the inputs are high, that is 1, we'll only have a high output. However, the output is low if any or all the inputs are low. That's why we'll obtain 0, 0, 0. Now let's draw the symbol of an AND gate. Let's draw the symbol of an AND gate. We can clear which part. The symbol of an AND gate. Symbols of AND gate. We draw the symbol of an AND gate. So this one is A and B, and this one is A dot B. A dot B. So we didn't have this one. This one is A dot B. Didn't have that one. A dot B. It's having multiplication operation. Now, let's talk of the last one. Let's talk of the last one. You can write this other side. The last one is the most easiest. It is called a NOT gate. The last one is the most easiest. NOT gate. NOT gate. NOT gate. Now, in a NOT gate is also called an inverse gate. Inverse gate is also called an inverse gate. And it's simple like this. This is the symbol of a NOT gate. Now, when we have here an A as an input, we are going to have an A inverse. So, if you are going to have, for example, we have an input as 0, the output will be 1. Now, drawing the truth table of a NOT gate is very easy. NOT gate, truth table. This one is the input. This one is an output. So we have A and A bar. So if you have 0, we will have 1. When we have 1, we have 0. And the output. So this is the only gate with 1 input and 1 output. It's the only gate with 1 input and 1 output. Very good, very good. So you can say this, NB is high only when all the inputs are low, if any of the input is high, the output is what? Is low. If any of them is high, then the output is low. Then the output is low. Now we want to talk of combination. So these are three major or three basic logic gates. The first one is an OR gate, the second one is an AND gate, and the third one is a NOT gate. I think we have explained it very nicely. Now let's proceed further to other gates. So, another gate we are going to talk of combination of basic gates. Combination of basic gates. The first one we are going to talk of is an AND gate. AND gate. There are only two combination of basic gates. There are only two. The first one is an AND gate, and the second one is we have a NOR gate. A NOR gate. So let us discuss the first one. The first one is an AND gate. Let us discuss AND gate. AND gate. AND gate is a combination of AND gate and a NOT gate. Is a combination of AND gate and a NOT gate. This is how we obtain that. This is an AND gate. This is an AND gate, as we have done it previously. A and B. Then the output will be A AND gate. AND gate is A dot B. Then NOT gate is a combination of AND gate plus NOT gate. So we have a NOT gate here. We have a NOT gate there. So when you combine AND gate and a NOT gate, this is what we are going to have. A dot B bar. A dot B bar. So this symbol, let's draw its truth table. For you to understand better, let's draw the truth table. The truth table of AND gates or NAND gates. Sorry, AND gates. So we have input and output. So under input, we have A and B. Output, the first output is A dot B. The second output is A dot B bar. A and B. Now this one is 0, 0, 0, 1, 1, 0, 1, 1. Now 0, 0 in a NOT gate, this one is 0, this one is 0, this one is 0, and this one is 1. Now, when we invert it, we are going to have 0 here, 1, 1, 1, and 0. So this is the truth table of an AND gate. And the symbol of AND gate now, that is just a combination. The symbol of AND gate is drawn like this. So this one is A, this one is B. This one is A dot B bar. Dot B bar. So you can say something small on an AND gate. Say AND gate is always 1 except when all of the inputs are 1. When all the inputs are 1, when all the inputs are 1, you're going to have a 0. You're going to have a 0. Now, let's continue and discuss on OR gates. Let's discuss on OR gates. OR gates. Now, in an OR gate is a combination of OR plus NOT gate. We are going to have a NOR gate. This is how it's drawn. This is an OR gate. Plus a NOT gate. What are we going to have? This one is AB, A plus B, A plus B bar. Now we draw the truth table. This one is the input and the output. Therefore, this one is AB, A plus B, and then we have A plus B bar. 0, 0, 0, 1, 1, 1, no. 0, 0, 0, 0, 1, 1, 0, and then 1, 1. Very good. Now, when we have 0, 0, we are going to have 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1 in an OR gate. But when it passes through a NOT gate, we are going 0. This one is 1, 0, 0, 0. So this one is a NOT gate. Let's draw the symbol of a NOT gate here. Symbol of a NOT gate is drawn like this. The symbol of a NOT gate. This one is A, this one is B, A plus B bar. Take note of that. You can say, or you can see, if high, only when all the inputs are low. If any of the inputs is high, the output is low. That is for a NOT gate. Now in a combination basic gates, we only have two, an AND gate and a NOT gate. An AND gate is a combination of AND gate and a NOT gate. And NOR gate is a combination of OR gate and NOT gate. And we can see the truth tables. We can draw them very nicely. Now, let us discuss something else. And what we want to discuss is universal gates. Universal gates. Maybe you can ask what is a universal gate. Maybe you are an electronic guy. You have been sent with your client to go and buy some gates. And you are able to find an AND gate. You are able to get an AND gate. An AND gate. And you don't need to use these gates. Maybe your job require another gate. Maybe it needs some basic gates. Now, how are you going to use these AND gates to implement other basic gates? How are you going to use these gates to implement other basic gates? And that's why we can call AND gate as an universal, gate. A universal gate, these are implemented gates. Now let's start with the first one. You have this AND gate, but you want a NOT gate. Now, how can you implement a NOT gate using AND gate? How can you implement a NOT gate using AND gate? So, of course, you know how to draw a NOT gate. A NOT gate is drawn like this. That's the symbol of a NOT gate. And the symbol that we have is AND gate here. AND gate. And AND gate is drawn like this. Now, you want to use this NAND gate to implement a NOT gate. What you are going to do is very simple. Just take a wire and connect this. So we will have an A as an input and A bar as an output. A bar. So this one is an AND gate implemented. An AND gate implement a NOT gate. Let's see another one, AND gate. Let's talk of AND gate. AND gate, how can you implement an AND gate? The symbol of AND gate is like this. No, don't have that one. Good, so AB. So we have A dot B. Very good. Now, when you want to implement this, you are going to buy two of AND gates. Two of AND gates. And you are going to put them like this. This one is A, this one is B. And then you're going to add another one. Another AND gate, NAND gate. And you combine this with a wire and you join them. This is an example. So this one is A dot B bar and A B bar bar. A B bar bar. And that is the result. Let's talk. The last one is an OR gate. How can you implement OR gate using an AND gate? Very fast. An OR gate is drawn like this. This one is A and B. This one is A plus B. Now, this is an OR gate, an AND gate, an AND gate. We bring another NAND gate, another NAND gate, and then we combine these two with a wire so that you can have a one output. After there, you combine another one here. So this one will come there. So let's say this one is A, this one is B. When you enter here, it is A bar and B bar, right? And we need to have this one. When it comes out is A bar plus B bar or bar. And this one is the same as saying an OR gate. That is an OR gate. That is an OR gate. That is an OR gate. Let us discuss the last one. The last thing that we are going to discuss is an XOR gate. An XOR gate. The last one we are going to discuss is an XOR gate. An XOR gate. Remember, you can also use an OR gate to implement. You can also use an OR gate to implement AND gate, OR gate, and X gate. Now let's talk of exclusive OR gate. These are exclusive gates. And the first one, what we want to discuss, an exclusive gate, sometimes it's called an XOR. An XOR gate. Sometimes it's called an XOR gate. Sometimes it's called an XOR gate.